So good afternoon guys. So in this session we will see doubly linked list, right? So we'll see how we can traverse the doubly linked list. First we will see the forward traversing, then we will see the backward traversing. So first thing first. So let's first understand what is the structure of your doubly linked list. So in my doubly linked list, my structure consists of three parts. First is your left pointer, which contains the address of left node. Then there is a right pointer which contains the address of right node, and there is an info part which contains your data. So let's suppose this is your doubly linked list having the info values 10, 20, 30. Now since this is your first node, so if this is the first node, since there is no node behind this, so the left pointer will be null. Now since this is the last node and there is no node ahead of this, so this is null. So this is your RPT. It's a right pointer. Right pointer contains the address of next node. So here it is showing 200. Now for this node, this is your previous node. So LPT, it is a pointer which contains the address of your left node or previous node. Similarly, this is your right pointer. It should contain the address of right node. This is left pointer. It should contain the address of left node. So this is LPT. This is info. This is RPT. LPT contains the address of previous node, and the first node LPT is null and the last node RPT is null because there is no node ahead of this and there is no node behind this. So let's suppose this is the structure, where struct is a keyword to define structure, node is nothing but your structure name, LPT is your left pointer which is containing the address of left pointer, left node. Since this pointer is pointing to node, therefore the type of this is struct node, and there is an info part. My info is integer, so int info. RPT is a pointer which contains the address of right node. Since it is containing the address of right node, therefore the type of this pointer is of type struct node. There is a first variable which can access the members of the structure by using the arrow operator. Now first we will see how can we display this linked list, which means how can we move forward. I want to print the values like 10, 20 and 30. This is what I want on my output screen. So let's write a code for this. So I am writing void forward underscore traversing. I am writing this function. So I am taking a pointer struct node star ptr. Fine. I am assigning the address of first node to this pointer. So this is my ptr. Fine. Now I want to print the values 10, 20, 30. So what I require, I need a loop. So I am running a loop while, and I have to run the loop till what? Till the ending of a linked list, and ending denotes what? Your null. So I will run the loop while ptr not equals to null. If my ptr is not null, then I will try to print the values. I will write printf percentage d comma. Since my ptr is pointing at 100, right? So 100 info is what? 10. So I will write ptr arrow info, and my value of info is 10. So after printing 10, I want my ptr to this time point to 200, because when my again if I run a loop, so my pointer should point to 200, just like a normal for loop. For I equals to 0, 0 less than 5, or I less than equal to 5, if I want to print the values from 0 to 5. So let's suppose if I want to print the value from 0 to 5. What you do? You write I is equal to 0, I less than equal to 5, or I plus plus. So I plus plus means you're gonna increment the value of I. Similarly, after printing this 10, now my pointer is 100, pointing at 100. I want my pointer to point to 200 so that it can print the value 20. So how you gonna increment the pointer? You will simply write ptr is equal to ptr arrow what? Now this is your RPT. Do not compare it with the link. That is in case of single link, this is where the structure was struct node star link. But in this, my right pointer, which is pointing to the right node, this member is what? RPT. So I will write ptr is equal to ptr arrow RPT. Now let's run the code. So initially the value of ptr is what? ptr is 100. So 100 not equals to null, condition is true. Now if your condition is true, you are printing info part, and info part is 10. Now you are moving the pointer to ptr is equal to ptr arrow RPT. Now your ptr is pointing at what? 200. 200 not equals to 200 info is what? 20. Now you are printing 20 and you are incrementing the pointer to 200 arrow RPT is what? 300. Now 300 not equals null condition true. Again you are printing info part of 300 which is 30 and PTR moves to what? Null. So null not equals null condition is false and you will come out of the loop. So what you are getting? You are getting 10, 20, 30 as the output, right? So the difference between single linked list or circular linked list when you compare to the doubly linked list is in doubly linked list we have the address of the previous node also available with us. So not only we can do forward traversing, we can also do a backward traversing which was not possible in case of circular linked list or single linked list. So now this time we see how to print the linked list backward and I want the answer as 30, 20 and 10. So let's see. Okay. So initialize the pointer PTR is equal to first. So now my pointer is pointing to 100. So this is backward traversing. Now see, if you want the value 300 to be printed first, you want the pointer moving forward till it reaches the last node. So our first main objective should be that I want my pointer to point to the last node initially. So how we move the pointer to the last node? So we are doing it again and again. So while PTR arrow RPT not equals to null, PTR is equal to PTR arrow RPT, right? So I am writing PTR arrow RPT. Suppose if I had written only PTR not equals to null. So when you run this code, my PTR is pointing to null, but I do not want my PTR to point to null. I want my PTR to point to 300. So just like a single linked list where I told you that you have to write PTR arrow link not equals to null in order to reach to the last node. So in this case, my forward way of traversing is this is RPT. So I will write PTR arrow RPT not equals to null. PTR is equal to PTR arrow RPT. So once you write the code, debug the code that your PTR is now pointing at what? 300. Fine. Now what you want? Now you start printing the values. So we want to start printing the value from 30, 20, 10. So what I will do? I will again run a loop while PTR not equals to null, printf %d comma PTR arrow info. Now see what happens. Now since your PTR is pointing at what? 300. 300 not equals to null condition is true. So you are printing info part of 300. Info part of 300 is 30. So 30 gets printed. Now you want 20. So 20 lies at what? Which address? 20 lies at the address 200. So it means you have to move backward. And this backward pointer is nothing but it is your LPT. So from 300 you want to move to 200. So what you want? You want that PTR to point to 200 and 200 is nothing but the LPT part of PTR. So we write PTR arrow LPT. This is nothing but 200. You want to assign this 200 to your PTR. So PTR is equal to PTR arrow RPT. Now the value of PTR is 200. 200 not equals null condition true. Info part of 200 is 20 and PTR moves to what? 200 arrow LPT which is 100. 100 not equals null condition true. 100 arrow info is 10. Your PTR moves to null. Null not equals null condition becomes false and you will come out of the loop. Right? I hope it is clear guys. So thank you so much. Keep smiling. Bye.